So let's look at problem 7.10 in AOPS Introduction to Number Theory. How many perfect squares less than 500 are divisible by 8? Well, here, one trick to fall into is we realize that 8 is obviously not a perfect square, right? So 8 is actually 2 cubed. So to make this a perfect square, we can square both sides of this equation and get 64 is equal to 2 to the power of 6, or 8 squared. That's obviously a perfect square. And then we continue the problem by doing 500 divided by 64. But no, that's not correct, because there's a way smaller perfect square that is larger than 8, which is 16. If you multiply the equation by 2, we have 16 is equal to 2 to the power of 4, or 4 squared. So 16 is the smallest perfect square that is greater than 8. So that's what we're meant to do, and we take 500 divided by 16. It's 31, remainder 4, and what are we going to do now? So from 1 to 31, or actually, I guess you can say from 0 to 31. All of these integers times 16 is less than 500. So we have to find these integers from 0 to 31 that are perfect squares. Why? Because 16 is already a perfect square, so you can only multiply another perfect square by this. For example, a squared, right? And then as long as a squared is larger or equal to 0 and less than or equal to 31, then this thing is going to be, a perfect square that is less than 500 and divisible by 8. So we need all the perfect squares between 0 and 31 inclusive. That's 0, 1, 4, 9, 25. There are 6, so this means that there are 6 perfect squares here. Notice that one trick you might fall into again is ignoring the 0, because, you might assume that all problems involving perfect squares only count the positive squares. Well, that's not true. We have to count 0 here. There's no restraints here. There's no how many perfect squares that are positive are divisible by 8. There's no positive here, right? So we can include the 0. So we have 6 solutions, and that's actually just our answer. So that's our answer. So thanks for watching. Bye.